Okay, so an example on rotational motion, a bicycle wheel has an initial angular velocity of 1.5 radians. So we have here a given omega naught, which is given by 1.5 radians per second. And let us assume that here, okay, at this point, the initial velocity is located here, omega naught. And let us assume that counterclockwise is a positive nga rotation. Okay? So if its angular acceleration is constant and equal to 0.30 radians per second squared, what is its angular velocity at 2.50 seconds? So here, angular acceleration is given by 0.30 radians per second squared. So the only thing that is given is your time, which is simply equal to 2.50 seconds. So it's asking for what's the speed after 2.5 seconds. It might be nabot diriya ang particle. I don't know kung asa. Let's just guess. Or if nakatuyok na siya after 2.5 seconds. So let's just check. So here is that we're going to look for your four kinematic equations ng tao ninyo, and then it's looking for your final velocity after 2.5 seconds. So you'll have here omega. So here, first, equation number one, yes, possible siya. So mo lang equation ang pwede magamit since there's no angular displacement kang gihatag. So use equation number one. So you'll have omega is equal to omega naught plus alpha times t. So one tendency that would be 1.50 radians per second plus you'll have here plus quantity you'll have 0.30 radians per second squared times 2.50 seconds. So the answer is simply 2.25 radians per seconds. Okay, so yes, it is expected nga mas dako pa sa 1.5 since ni-accelerate man ang rotationally ang particle. Okay, since this is positive. Next, for letter B, through what angle has the wheel turned between t is equal to 0 and 2.5 seconds. So it's asking for at what angle here, at what angle theta does the wheel rotates. So let us see if naka 1 revolution ba siya or not. So a tendency is that here, same like given at the upper end, and then I additional given, but then it's looking for at what angle, theta. Okay, so let us assume that the initial angular displacement is located here, so theta naught is simply equal to 0. So here is that we're going to use equation number 2, 3, and then 4. So it's either of the three equations. You can use equation 1, no, not 1, sorry. Equation 2, 3, 4. So you'll have 2, pwede ka magamit og 2, equation 3, o equation 4. So ang equation 1, wala man siya theta nga variable, so sa pwede magamit. So ang pinaka sayon gamiton kay si equation 2. Okay, pero either of the three. So ako ganahan ko nga si equation 2, so you'll have theta minus theta naught is equal to 1/2, then you'll have omega plus omega naught times t. So your theta naught is simply equal to 0. Yes, and then Your theta is simply equal to 1 half, and then you'll have quantity final 2.25 plus 1.50, quantity factor out na to ang radians per second, and then ang time is equal to 2.50 seconds. So this time, seconds will be cancelled out. So ang answer is simply, that would be equal to 4.69 radians. So you'll have 4.69 radians. Okay, we are not sure kung pilay angle ani niya in degrees. So all we have to do is to what? Convert. Let's try to convert this one into degrees kung pilang angle ani niya. So ang tendency is that would be pi, and then you'll have 180, right? Tama. So ang tendency is that the answer for this one, this is also equal to 268 degrees. Okay, in degree. Okay, so wala pa siya nara siya sa third quadrant. Or, if you may like, you may also substitute this one in revolutions. Okay, so you'll have theta, which is simply equal to 4.69 radians. And then in revolution, so you'll have here radians here sa denominator, and then revolutions the numerator. So in one revolution, there are 2 pi radians. So that would be equal to 0.75 revolutions. So wala kabot og isa ka tuyukan. So that would be 3/4. So that would be equal to 0.75 revolutions. Second example, an electric fan with blades 0.75 meters in diameter is rotating about a fixed axis with an initial angular velocity of 0.25 revolutions per second. The angular acceleration is zero point 0.9 revolutions per second square. Compute the angular velocity after 0.2 seconds. So I've already drawn. This is simply, let's assume that the initial um, rotation of the fan is at this point, and then the final is at this point. So here, isulat natong given. You'll have initial angular velocity is given by 0.25 revolutions per second. So ang rotation is padalong the real rotation. Okay? So a tendency is that the alpha is given with 0.90 revolutions per second. And yes, the time is simply equal to 0.2 seconds. So for letter A, it's asking for the angular velocity after 0 0.2 seconds. So it's asking for its final angular velocity. So if you'll notice a given, walay theta or angular position nga gihatag. So first equation, you try to evaluate siya lang ang magpasar. Okay, so sa tanang equation, I forgot also to remind you, ang equation 1 kay equation nga walay angular position. Equation 2, equation nga walay angular acceleration alpha. Equation 3, walay final velocity. And equation 4, walay time. Okay? So here, let's go back. So isa lang ang pwede natong equation pwede magamit, and that would be equation 1. So one tendency is that you'll have omega is equal to omega naught plus alpha t times t. Okay, so ang tendency is that you'll have here 0.250 revolutions per second and then you'll have plus 0.90 squared, I forgot to put squared, revolutions per second squared times zero point 0.2 seconds. 0.43 revolutions per second. Okay, so here, gikag 0.25, nahimo siyang 0.43. Okay, for letter B, through how many revolutions has the blade turned in this time interval? So it's asking for how many revolutions. So one variable has a unit of revolution, and that would be theta. Okay, so it's asking for pila ka angular displacements iyang na travel for time 0.2 seconds. So here, it could either be you're going to use equations 2, 3, and 4. So you can use equation 2, 3, or 4. So the easier nga equation to use is this one. Okay, so I'm going to use equation 2 for this case. But you may try also using 3 and 4. So until then, you'll have theta minus theta sub 0, which is simply equal to 1/2, and then you'll have omega plus omega naught times t. So theta naught is simply equal to 0. Okay, this is our inertial frame of reference. Okay, so 0 nga angle na mag-measure diri or 0 radians. So ang tendency is that you'll have theta is equal to 1/2, and then we'll have here final 0.43 plus 0.250 revolutions per second times 0.20 seconds. So the answer would be 0.068 revolutions. Okay, kamay kay no wala ra siya kabot kini nga theta man yang gipangita. Kini nga theta. So that would be 0.068 revolutions. Let us see what is the tangential speed on the tip of the blade at 0.20 seconds. So basically, it's asking for the tangential speed of the blade. So at time, it has been specified 0.2 seconds. So basically, the equation for the tangential speed, if you still remember, this is simply equal to r radius times omega. So if you'll notice, there are two omegas. Here are two angular velocities, the initial or the final. But then notice nga gi-specify niya nga 0.02. So meaning to say, ang iyang gipangita nga tangential speed is this one. Okay. Kani nga V tangential. Although natay V tangential at this point here. But it's looking for V tan here. But then take note, look at your final velocities. Okay, ang unit niya is wala naka-SI. So first things first is we need to solve for the SI unit niya. I-convert nato to SI unit. So here, what we're going to do is simply mag-multiply ta og revolution sa denominator, right? I-rearrange nato ni siya ha. Para makita ninyo revolutions per second. So here is that revolution sa denominator and then radians. So take note that in one revolutions, there are 2 pi radians. So a tendency is that this is simply equal to 2.70 radians per seconds. Okay, so next, the only thing that is given is ang diameter sa blades. So all we have to do is divide this diameter by 2 in order to get the radius. So you'll have here radius, half of it is simply 0.750 meters divided by 2 which is equal to 0.375 meters. Okay, so we are now okay. We're going to calculate for V tangential, which is simply equal to 0.375 meters multiplied by 2.70 radians per second. Ang purpose nga nung ESI nato sila is because ang final answer is simply, ang unit is simply in meters per second. Ang radians ngayon is being omitted. So this is simply equal to 1.01 meter per second. Okay, next for letter D, what is the magnitude of the resultant acceleration on the tip of the blade at time t equal to 0.2 second? So again, it's asking for the magnitude of the resultant acceleration. So it's asking for the magnitude of the linear acceleration. So take note that here, there are two acceleration present. So, ang tendency na kay tangential acceleration o radial acceleration at this point here. So, kaning final. So, meaning to say, I have here, this will be your tangential acceleration, A tan, and the other one is your radial acceleration or centripetal acceleration sometimes, as they call it. So, ang tendency is that pagpangita sa magnitude, so dili kayo perpendicular ang pagka-draw. Excuse me. So, ang tendency is that you'll have here, you'll draw a line parallel to your A radial and also draw a line here parallel to your A tangential. Okay, so it's looking for the magnitude of your radial acceleration. Okay, one yung mga linear acceleration. So here, the magnitude of the linear acceleration A is simply equal to the square root of A tangential squared plus A radial squared. Okay, so as you notice, I already converted each of the values to SI. So again, I repeat, ang gibatan ako diri kay ang conversion factor ko gamit conversion factor I place revolution sa denominator para ma-cancel out. Okay? So, here and take note ang value sa pi 3.14. So, here is that A tangential ang equation kay R alpha, right? So, you'll have R alpha and then squared plus radial is simply omega squared R. So, you'll have omega squared R and then squared. So all you have to do is simply square root of, you'll have here R, which is 0.375 meters, times its alpha, which is 5.65, 65 radians per second squared, radians per second squared, quantity and then squared, plus the tangential. So you'll have here, naka-square ni siya. So that would be 2.7. So you'll have 2.70 radians per second. And then multiplied by R, 0.375 meters. Okay, and then squared. So the final answer is simply in meters per second squared, and that would be the magnitude of the linear acceleration. That would be 3.46 meters per second squared.